Hi everyone, we're going to find the sum of the series for the sum of from L equals 1 to N times the sum of K equals L to N of K. And a trick to do this one, since we have this thing going on right here, let's look at this inner sum right there. And that's going to equal, so I'm going to say the sum from K equals L to N of K. I can rewrite that as the sum from K equals 1 to N of K minus the sum from K equals 1 to L minus 1 of K. And that's because if you take this lower part, K equals 1, and take 1 plus L minus 1, you get L. So as long as we subtract it, then these are equivalent to that. So now let's just fill in the formulas here. So this one is going to be this formula here, and that's going to equal N times N plus 1 divided by 2. And you're just taking this upper one. And the same thing happens here, but we have this L minus 1. So this is going to be 1, or L, 1's and L's look the same. L minus 1 times L divided by 2. Now, simplifying this is going to give me, I'm going to pull out the 1/2. So this is going to equal 1/2 times N plus 1, and then minus, and then for this I'm going to distribute and distribute this negative. So this is going to be minus L squared plus L. All right, now let's go back to our original problem. So we know what this equals. So we have basically this whole thing equals 1/2. I'm pulling out the 1/2 from the original. We have the sum, and I'm writing this one here. L equals 1 to N, and then I'm going to write down what we just got. N times N plus 1, and then minus L squared plus L. All right. Now I'm going to go ahead and distribute this sum. So now I have 1/2, and for this piece we get the sum from L equals 1 to N times N times N plus 1, and then minus the sum from L equals 1 to N of L squared plus the sum from L equals 1 to N L. And now we just use our formulas. So basically this one right here, and this one's kind of confusing. So basically looking at this, we're substituting an N. But if you look at this, you have N times N plus 1. This is N squared plus N. And so when you're substituting in the N, you're going to get N cubed plus N squared. But we want to leave it out. So basically all this is this one times N. That gives you that. So we're going to have 1/2. I'm going to do this in red. And then we're going to have N times N plus 1 times N. All right, so that's this part. Now this part's minus, and this is L squared, and that's this formula here. So you're going to write this as, and we're going to N. So this is going to be minus N times N plus 1 times 2N plus 1 divided by 6. And then this one is the normal one we're used to. So this one's just going to be plus N times N plus 1 divided by 2. All right. And 1/2 times all of that. Now the next step I'm going to do, which I'm going to do on the next page, is I want to get a common denominator for everything. So my common denominator is 6. So that means if I want a 6 here, I have to multiply this by 6, this whole thing by 6. And if I want a 6 here, I have to multiply this all by 3. Right? So I have my common denominator as 6. So in the next slide, I'm going to pull out the 1/2 times 1/6 and simplify all this. And I'm going to also factor out n times n plus 1. All right, that's going to give me 1/2, and I'm factoring out now the 6 part, the 1/6, and the n times n plus 1. And what's left is going to be 6n minus 2n plus 1 plus 3. All right, this leaves me with 1/2 times n plus 1 divided by 6, and this is going to be 4n plus 2. All right. Now, when you simplify all this, we're going to get, let's see, this is going to be 1/2 times n squared plus n times 4n plus 2, all divided by 6. And this is going to all simplify. When you simplify it out, you can take this 2, and this is going to go into this 2 times and this 1 time. And then we're going to be left with n times n plus 1 times 2n plus 1, all divided by 6. And that is your final answer if you factor it all out. Have a nice day. Bye-bye.